Hi, welcome to the Calculus 3 assignment worksheets series, and we are still in the this unit, partial derivatives. This is our last assignment worksheets. We're going to talk about the Lagrange multiplier. So we're going to do a few problems about the Lagrange multiplier and to learn some technique how to solve those system of equations here. Okay, and so let's go to the worksheets and let's start to work. All right, so the first problem I'm going to do, it will be the problem number 1 here. So the number 1, I really like those picture type of the problems. It's really kind of give people a very good visual. What is a Lagrange multiplier mean? Okay, so the picture shows is a contour map of the F. Is this blue one curve with the equation, and the curve with equation gxy equal to 8. That is this red ones here. So we want to estimate the maxima and the minima values of the F subject to the constraints here. Okay, so I know when they meet, that means, the Lagrange basically will tell you is del F is equal to a constant times the del G's, right? So like for these problems here, so that means the level curve, they will touch. So I know this will be the level curve where they touch here. And also because this is gradient vectors, right? So the gradient vector for the my f of x is go this way. So it's the same as the gradient vector for the gxy's here. So I know this level curve probably will be the one. So I know the maximus here. So the max is going to be around what? Around like this level curve is like 60s, right? Okay, now let's take a look at another one. When they go out, it's getting smaller. So I think the next level curve is like these two level curves touch at here, okay? So it's very close. So this is the line. So here, I think this is the level curve line. So the same way, the gradient vector, they will go the same way. They both perpendicular to the gxy's level curve and f of xy level curve. So what is my minima values here? The minima value is this level curve is here. So it should be around what? Around 30s, right? Okay, so this is pretty straightforward. Okay, so now let's take a look at problem number 2 here. And so I'm going to work on this one here, the problem number 4. So f of xy equal to 3x plus y, x square plus y square equal to 10. Okay, so let's just, I'm going to start out here because I need more space here. Okay, so I will have row f here, right? So the row f here will be what? F of x, so it's 3. Row y is 1. Okay, so this is my constraints, right? So this is gxy here. Okay, so the same way I have del g is what? Is 2x, del y is 2y's, right? Okay, so now I can put it together. So I know the 3, 1 is equal to a lambda times 2x, 2y's here. Okay, so now we can say this is 3 is equal to 2 lambda x, and the 1 is equal to 2 lambda y's here. Okay, so then I know, you can, so the divided by 2x both sides, so the lambda going to be equal to 3 over what? 2x here, right? And the same way, the lambdas here going to be what? The lambda going to be 1 over what? 1 over 2y's here, okay? And because also you know, so for the here, so this is lambda and 2y. So now we have so this is 3, so both of them, those are the lambdas, right? So they will equal to what? They will equal to each other. And I can kind of cross out these constants, make it a little easier. So now I have what? A cross product, I have 3y equal to what? Equal to x here. Now I have my conditions here, the x squared plus y squared equal to 10. Then I substitute here, x equal to 3y, so x squared is equal to 9y squared plus y squared equal to 10. So what I have here, I have a 10y squared equal to 10. So what I have here, y squared equal to 1 here, right? So then the y squared equal to 1, then y can have a positive 1 or y can be negative 1. Since 3y, since here we say 3y equal to x, so we can say, okay, when the x equal to the positive 1, then the x equal to what? X equal to 3, and y equal to negative 1. So what is x? X equal to what? Negative 3, right? So we have, so I know by the Lagrange, the extreme points are going to be at what here? 3, 1, or negative 3, negative 1 here. Now I plug in f of 3, 1. So f of the 3, 1, so 3, so it's 10, right? Okay, and then the f of negative 3, negative 1, so it's negative 9, so it's negative 10. Okay, so that's where is my extrema. So this will be my max, and this will be my what? This will be my mean, right? Okay, so now that's going down. So the remaining problems, so here are pretty similar. You just, try to solve it. Okay, so the number, I'm going to do a number 11 here, okay? So for the number 11, this one has some special way to solve it. I think I need to give more space here maybe. So I'm going to the reason why I choose the number 11 because it has some special methods to solve this type of the problem. Okay, so let's start. Okay, so let's take a look at del f here. Del f is 2x, 2y, 2z's, right? Okay, then the del g, as always, this is a constraint. The del z is 4x3, 4y3, and 4z3, correct? Okay, so now we do the del f equal to the lambda del g. Okay, so then I can get my first equation is 2x equal to 4 lambda x cubed, right? Then I can also get 2y is equal to 4 lambda y cubed, okay? So here, this is 2z is equal to 4 lambda z cubed here, okay? So z cubed here. So right now, I'm going to solve the situation. So first, remember, so we want to solve, if I can find the lambda, then I can substitute the lambda, and then we can find my values here. Okay, so let's take a look at the situations number 1. Okay, so this is the situation number 1. So the situation number 1 is here, okay? Let's say here, because I want to solve lambda, right? So let's say situation number 1 is x is not equal to 0, y not equal to 0, z is not equal to 0. Okay, so if this is a situation, then I can divide by So for first equation, I will get a what here. So if you divide by 4x squared both sides, right? So I will get this is 1 over 2x squared. So the same, the lambda for the second equation, you can get this is 1 over 2y squares, right? And then the third equation, you can get this is 1 over 2z squares, right? Okay, so because all this is lambdas, right? So I can say this is 1 over x2 squared equal to 1 over 2y squared and equal to 1 over 2z squared, right? So you know the reason why it's right. So the here, why the situation number one is this one's here, because then I can put the x, y, z in the denominators, right? Okay, so here I can kind of get rid of this 2, 2, 2. So from here, what I get here, I say, okay, I know the x squared equal what? To the y squared equal to the z squared. Okay, so if xy squared equal to the z squared, then I substitute back to my constraints here. Okay, so that's okay. So that means x squared. So let's see here. So it's x squared, x fourths, right? Plus y squared equal to x squared. So this is another x what? Another x fourths. And then z squared equal to here. I have another x fourths. So it's equal to 1. So for these ones here, I have 3x fourths equal to 1. So what is x fourths equal to? 1/3, right? So now I take the roots. So x will be equal to plus minus, so the roots, fourth roots here, right? So like x is equal to the plus minus 1 over 4, the square roots square roots of the 3's, right? Okay, so now because this one, so my possible extreme for the situation number one, because x equal to here, so I have so many situations. I have 1 over square roots of the 3 to the 4th, and the 1 over 3 roots of the 4th, and the 1 over roots of the 4th, right? This is plus minus, plus minus. So you can have all kind of a combination. But luckily, when we substitute to my fx, y, z's here, because they're all squared, you substitute to here. So what is my here? So for this set of the value, when you substitute, I get is square roots of the 3's here. Okay, so let me try to let me try to circle this. So this is square root of the 3. Okay, so now let's take a look at the situation number 2. Okay, so the situation number 2 is here. Be careful, see here, right? So situation number 2, I said, how about the 1 of me is equal to 0? Really doesn't matter which one, because this is it's symmetric, right? X equal to 0, y equal to 0, z equal to 0, the same. So how about the 1 of me is equal to 0? So let's say, let me see here. So if 1 of me equal to 0, let's let, okay, so let's let the x equal to 0, all right? So let's say the x equal to 0. Okay, if x equal to 0, then I cannot use the, okay, so here, let me circle that. So if 1 of them equal to 0, so we say we let the x equal to 0. Okay, if x equal to 0, then the only thing we can find is the 1 over 2y squared equal to 1 over 2z squared, right? So I'm just using these two, right? So I'm just using these two here, because now x equal to 0, I cannot divide by 0 here. Okay, so it's y squared equal to z squared. So I can come out with y squared equal to the z squares, right? Okay, if y squared equal to z squared, then I bring back to my here the constraint x equal to 0, so it's 0. So it's 0 plus y force plus z force, right? Because z squared equal to y squared. So this is another y force is equal to what? Is equal to 1. So I have a 2y force equal to 1. So what is the y force equal to? Y force is equal to 1 over 2. So what is the y going to be? Y going to be plus minus 1 over 2 to the how many roots? It's 4 roots, right? Okay, so it's the 4th roots. So now the possible extrema will be what? It's a plus. Okay, so the possible extremas here and here, x equal to 0, right? So I have, okay, so the possible extremas here will be x equal to 0, right? So it's x equal to 0. Then y is equal to the square roots of the 2 plus minus 1, that is 4th roots. Then z is plus minus 1, the roots 2 to the 4th roots here, right? Now you plug back into your functions here, right? So you plug back in here. So the f of x, y, z, right? So this is x squared plus y squared is 1 over square root of 2, z squared is 1 over square root of 2. So this one's here, what you get here? So this one you will get is the square root of 2 here. So I'm going to circle this one. So this is another extrema because later we're going to compare. Okay, so the last situations, right? So we say the situation number 3 is here. The situation number 3, and this is the situations. I'm only have 1. So both of the, so that means how about 2 of them equal to 0. So if 2 of them equal to 0, okay? So let's say I will use y and z equal to 0, right? So I said y equal to 0, z equal to 0. If y equal to 0, z equal to 0, so what is my constraints here? My constraints here will give me x force equal to what? X equal to 1, right? So what is my x here? So my x will be plus or minus what? Plus or minus what here? Plus minus 1. So what is my possible extrema? Will be plus minus 1 and 0, 0. So if you substitute to that, f of x, y, z is 0, 0, and 1. So what is here is 1, see here, right? Let me circle that. Okay, so this is 1 here. So those are the possible extremas here. So now let's compare where is the max, so where is the mean. Okay, so the maxima here, it will be what? Will be the square root of the 3. Here, the local max here is the square root of the 3, right? So where we're going to be happen, we're going to be happening these 8 different combinations. Now, where is the, where is the minimum? Minimum is here, right? So it's x, y, z equal to 1. So where that going to happen? It's going to happen at these 2 points here. Okay, so this is a kind of very common type of the problem. It's kind of like a lot of people like to put those type of problems there because it does require a special skill to solve it, right? So that's why I was, try to work on these problems. So demonstrate that this is a part of the one of the technique you can use to solve this type of the problems here. Okay, so now the next problem I want to solve is, let's going down, see here. Okay, so I'm going to solve this one, see here, the number 19 here, right? So in here, we need to be careful here. So let's say, hey, I want to find the extreme value on the region. described by the inequality. Okay, so instead of like you have level curves, right? So because of the inequality, this is x squared plus y squared less than or equal to 9. That means I'm going to find the extrema. This is a circle, right? So this is a circle with radius is 3. So let's say, hey, find it less than or equal to, less means it's the whole area. So in here, whole area, because here I have equals, right? So that means what? I also need to consider what happened here. I also need to consider the boundaries, right? So we know the interior, I can use critical point. The boundaries here, you know, so that's why in here we can use Lagrange to find the boundaries here, right? Okay, so let's start here. Okay, so that means here, so for the interior point, so because remember that's what we said, we need to check every point, right? So for the interior point, where is could be the max or mins here. Okay, so for all the interior points, we will find the critical point. Okay, and then for the boundary, we're going to use you know, the Lagrange to find it, right? And I think we did this in the previous, I don't remember exactly which assignment. And like remember we have a triangle, and then we need to put each line back to here, right? So now you will find out if you use Lagrange, it's a lot easier, right? So let's try to see how you still remember how to find the critical point. So the critical point is a partial derivative f of x. So what is f of x? Is 2x plus 4. We set this one equal to 0. Then f of y, so y is 2y minus 4 equal to 0. So I will have x equal to the -2 and the y equal to what? X to 2. So that's pretty easy to find the critical point. So my critical point here is -2 and 2. So here, right? So if you plug back into the f of x, y, so you put it back in here, the 2 and the -2. So it's 4 plus 4 minus a. So okay, so it will be negative. It will be -8. Okay. So let me circle this one here. So this is the one we're going to compare to. Okay, so now I want to find all the points on the, on the boundaries here. So now we learned the Lagrange, we can. So for all the boundary point, we will use Lagrange. Okay. So here, so let's do again. So del f. Okay, so del f is 2x plus 4. Okay, and del f of y is 2y minus 4. Good. And then the del g, right? So del g is 2x and 2y, right? Okay, so now I have the del f equal to the lambda del g. So I have a 2x plus 4 is equal to the 2 lambda x. And we have a 2y minus 4 equal to the 2 lambda y here. Okay, so, oh boy, let's see how do we solve it. Hey, here's a plus minus, right? So let's try to add it up to see what do we have. So I have here, this is a 2x plus 2y is equal to the 2, hey, that's pretty good, right? So I have a 2 the lambda x plus y. And then this one's here, you can factor the 2 out, 2x plus y equal to the 2 the lambda x plus y. This one we can cancel, right? So now I can say here, so I can say x plus y minus lambda x plus y equal to 0. I factor x plus y out, and 1 minus lambda equal to 0, right? So when you times the two numbers, right, equal to 0. Okay, so when you times the two number equal to 0, then let's see here. So that means what? That means this one equal to 0, this one equal to 0. Okay, so let's see here. Let's say that, hey, how about lambda equal to 1? Is this work? Lambda equal to 1. I said, this is not working. Why? Why is it not working here? Oh, because if you substitute this equation here, right? If you put it in this equation, let's see what happens here. So that means 2x plus 4 equal to the 2x. Cannot be, right? Can be, all right? So that's why I know lambda cannot be equal to 1. So that means this item cannot be equal to 0. So the only other item possible can be 0 is what? X plus what? X plus y equal to 0, right? X plus y equal to 0. That means y will be equal to the negative x, all right? So now let's put back to my constraints here, right? So I know that x equal to y equal to the negative x, right? So that means my constraints here is x squared plus y squared equal to 9. So x equal to negative y. So this is y squared plus y squared, okay, is equal to what? Equal to 9. So y squared is equal to the 2 over 9. So y is equal to what? Plus minus 3 over square root of 2 here. Okay, so with these ones here, then I will have a possible extrema. Okay, so when the x equal to, so when the y equal to the positive 3 over square root of the 2, because x equal to the negative y, right? So that means then the x is going to be negative 3 over square root of the 2. Also could be the y equal to the negative 3 square root of the 2. Then the x is negative y. So what is here? This will be the 3 square root of the 2. Okay, so now you plug back into the f of xy. So I can plug back in. This one here is negative 3 square root of the 2. And this is the 3 square root of the 2. Then if you plug back in, so I get this numbers here is 9 minus 12, the square root of the what? 9 minus the 12, the square root of the 2 here, all right? And then the same way, if you plug in this one, so this is 3, the square root of the 2, then this is negative 3. Okay, so this is negative 3 square root of the 2, right? So you plug this one back to your function. So what do you have here? You have this is 9 plus 12, the square root of the 2 here, okay? So let me circle it. Okay, so let me circle it here. So like in here, okay, so here, okay, so let me circle it. I get the same color pens here. Okay, so I'm going to have this value, and I'm going to have this value. So I'm comparing, right? So obviously, both these two as negatives, right? So I know this one has to be what? The max, right? So let's take a look at the 12 and the square root of the 2. What is this value here? And minus, okay, so 9 minus 8. Okay, so let's see here. So this one's here going to be equal to, so this one going to be equal to negative 7.97. Oh, pretty close to the, okay, so now what is my minima here? This one is going to be what? My minima. So my minima going to happen on the, oops, on the critical point, and where is my maxima happen? My maxima going to happen at the boundaries, right? At the boundary of the circles here. Okay, and this one's here is pretty kind of the pretty important one. So it's kind of a little bit different than what we have here. So in here, because of inequality, that means your area, the region you are considered is like closed regions here. So you have the interior points, and you have boundary points here. Okay, so let's do another easy ones here. Let me see here. So all the other you'll be able to follow the same ways here, right? Okay, so now let's take a look at the number 27 here. They said use the Lagrange multiplier to prove that a rectangle with the maximum area that has for a given perimeter is a square. Okay, so now for any rectangles here, right? So this is X and Y. So I know the area is what? Area is XY. So what is my constraint? So that the area is equal to the f of XY. So what is the constraint? The perimeter is P. That means 2x plus 2y equal what? Equal to P. So this will be my GXYs here, right? Okay, so now let's do the Lagrange multiplier. So it's pretty cool, right? So we do the gradients here. So fx is y, and this is x. And the del g's here is 2 and 2. Okay, cool. So now I know y is equal to the 2 lambda. Okay, and the x is equal to the 2 lambda. So in fact, it's pretty easy to prove. So the lambda equal to the y over 2, and this is lambda equal to the x over 2, because they both equal to lambdas, right? So what I have here, so I have y over 2 equal to x over 2. So what I have x equal to what? X equal to y. So the x equal to y, this is so the x times y, right? So x times y, this is the area. So this equal to the x squares, right? So this is the area for what? For a square, right? So it's pretty easy to prove here. Okay, that's it. And I think that is the, okay, so I think that is the problem. I think here, let's take a look and okay, I'm going to do one more for this ones here. This is the setup of the problem, and we're not going to solve it. We're just going to set it up to see what is the, how do we set up here, right? So here, okay, so let's take a look here. So let's say the plane x plus y plus 2z equal to 2 intersect the parabola z equal to x squared plus y in an ellipse. Find the point of this ellipse that are nearest to the farthest from the origins, all right? So the points on this ellipse is nearest to the far end of the origins here. Okay, so now I have 2 constraints here, right? So here, let's just set it up. First constraint here is this plane, right? This plane going to intersect this parabola, right? So I know, okay, so that's why I have 2 constraints. So first my constraints is g, x, y, z is equal to the x plus y plus 2z, okay? And then my other constraints here is h here, x, y, z is equal to x squared plus y squared minus z, right? Okay, so what is my objective function? We want to find the distance from the origins here, right? So my f of x, y, z, so the shortest nearest distance. So from the origin, because I know the distance formula is like x1 minus, so it's x squared plus y squared plus z squared. This is a distance to the origins, right? So if I want to find the, so I want to find the nearest to the farthest, I want to find the extrema. So it's the same, you can find just these squares, right? So this will be my objective function, the z squares here. So now we can do the same things here. Del f here is 2x, 2y, 2z's, right? And the del g's here is 1, 1, what? It's 1, 1, 2's, right? And then what is del h here? So the del h here is going to be 2x, 2y, and the negative 1. Okay, so because right now I have two constraints, so I will say del f, right? Del f is equal to the lambda 1 del g plus the lambda 2 del h here. So now let's try to list my equations here. So the equation number 1 is here. So this is 2x is equal to lambda 1 plus 2 lambda 2 the x. All right. Then the second equations will be 2y is equal to lambda 1 plus 2 the lambda 2 the y. Then my third equations here going to be 2z is equal to 2 lambda 1 minus, right? So 2 lambda 1 minus lambda 2. Okay, so see here, I have how many variables? I have x, y, z, right? X, y, z. Then I have lambda 1, lambda 2. So I have 5 variables. If I have 5 variables, I need to have 5 equations. So the remaining 2 equations will just be your constraints. So it will be x plus y plus 2z equal to 2. And then this ones here will be z equal to the x squared plus y squared, right? So this is our system. Okay, so in here we just want to set it up, and then we'll be able to solve it. And then we can find the extrema at a certain point. That means to give you the shortest or the farthest distance. So here. Okay, so that's it. And this is very interesting section, and I think it's a very useful section. Like I mentioned before, the algebra part is kind of hard, so just be careful. So the first things here, you need to be able to know how to set it up. And also in this assignment, we introduced a couple new kind of technique, skill, how to solve it. Okay, and I hope this video help for these assignments. Okay, have a good day. Okay, bye.